Hello and welcome back to Get Great at Maths. I'm here to help you pass your maths exam, so hit that like and subscribe button. We're going to look at keywords, key formulas and how to gain top marks. So let's get ready to get great at maths. We're going to look at the key facts that you need to know for GCSE when you're transforming graphs. And we're going to be specifically looking at trig functions today, but the key facts are exactly the same for any graph. So our first key fact we're going to be looking at is the graph of y equals f of x goes to y equals f of x plus a. Now if I think about the graph of y equals x squared, and then I translate that by a units in the y-axis, my new equation becomes y equals x squared plus a. So the original graph has been shifted up by a units. So we say that is a translation of a units parallel to the y-axis, or a translation of 0a, and we can write that as a vector. We could do a similar thing in the x-axis, so y equals f of x goes to y equals f of x minus a in brackets. So this time if I start off with the equation y equals x squared, putting it in brackets gives me y equals x minus a all squared. Now the new point that has just appeared, has been shifted across, so the x minus a, if you put this bracket equal to 0 and solve, you get a value of x equals a. So this is why it is shifted to the right this time. So my translation is a units parallel to the x-axis, or a translation of a0. So this moves in the x-axis. So these are our first two facts. Write them down, make sure you highlight them, and you make sure you know those exact facts for the exam. The next two transformations I'm going to look at are involving negatives. So if I've got y equals f of x goes to y equals minus f of x, so if I think of the graph of y equals x squared again, the minus in front of it means I get y equals minus x squared, which is a sad face graph, and it has been reflected in the x-axis. So this is a reflection in the x-axis if the minus is in front of the f of x. The second one I get is y equals f of x goes to y equals f of minus x, where the minus x is in brackets. Now this time if I think of a graph of y equals x cubed, now this time when I work this one out with minus x cubed, so it's in brackets, the graph is actually reflected in the y-axis. Please write down these key facts and make sure you've highlighted them and you know them for your exam. Now the four transformations we've looked at so far, we're going to be looking and applying to the function y equals sine of x. So have a go at drawing y equals sine of x, press pause and then press play when you've got an answer. Okay, so well done if you've drawn out the sine curve correctly. The key things that you need to know about the sine curve, you need to know that it starts at the point 0, 0. Okay, it comes up to a maximum at the point 91. It comes down back to the x-axis at 180, then it goes down to a minimum at -1 where we're at 270, then comes back to 0 at 360. They're the key facts you need to know for the sine curve. Now the centre of this curve is always about the x-axis in this case when I have got the function y equals sine x, and we're going to be looking at this centre line and seeing what happens to this centre line as I transform this function y equals sine x. Now in the top left hand corner up here you can see I've got the function y equals sine x that we've just drawn, and we're going to be looking at the trig function y equals sine x plus 2. And we're going to look at the transformation rules to see what happens to this sine x graph which is up in the top left hand corner, what happens when I add 2 to it at the end. Okay, press pause, then press play when you've had a go at drawing the new graph. Okay, well done if you managed to draw this. So what we've noticed is this now central line has shifted up by 2. So the plus 2 here on the end has shifted the whole graph up by 2. Now we could say that this is a translation of 2 units parallel to the y-axis, or I could write it as a translation of 0, 2. The next trig function we're going to draw is the function y equals sine x minus 1. So we're going to be looking at what effect this negative 1 has. Now we're always going to go back to the original graph that we started with, which was the y equals sine x function. So have a go at drawing out this graph of y equals sine x minus 1. See what happens when you draw it. Press play when you've got an answer. So this graph has now shifted down by 1. So you can see here now is my central line here, and it is down at minus 1. So the whole graph from where it was at the top has actually come down by 1. So every point has moved down by 1 point from where it was previously. Now we can describe this and we can say it is a translation of -1 units in parallel to the y-axis, or I can write that as a translation of 0, -1. Now you would get 2, possibly 3 marks for this in the exam for being able to explain that there's a translation, how many units it is and what axis it is in, to give you the 3 marks or the 2 marks depending on what the question states. We're now going to look at a trig function where we've got brackets and we've got the value inside the bracket. So I'm going to look at y equals sine of x minus 45. Now this sine of x minus 45, we're going to relate it to the original graph y equals sine x. What happens now when I've got an x minus 45? Can you draw the new graph? Press pause, have a go at drawing the graph, press play when you're ready to see the answer. So the graph you should have drawn will be looking like this. Now the key fact on this is we've got a -45 here, which means that we've got a 45 at this point here. So my 0 line to start with, where the graph started from, was at 0. And instead of now being at 0, it's shifted across to 45. So the curve is starting from 45 this time, rather than starting from 0 at the front where it was initially. So initially the sine curve starts at 0, 0, but now the sine curve is starting at 45, 0. So that's what effect it's had. We say this as a translation of 45 units parallel to the x-axis, or we can write it as a translation of 45, 0. Again, this time I've got a function in the bracket, so I've got y equals sine of x plus 90. We're going to go back to the original sine curve, y equals sine x. What happens to the graph of y equals sine of x plus 90? Have a go at drawing the graph, press pause and then press play when you're ready to see the graph. So well done if you got this correct. So the key fact on this is now that the start point is at minus 90. So here my sine curve is starting from the point minus 90. Initially it started from 0, 0, and it has moved from this point 0, 0, and it's moved to the left by 90 or -90. So the sine curve starts here at minus 90 and then completes the cycle. We describe this as a translation of minus 90 units parallel to the x-axis, or it is a translation of minus 90, 0. We're now going to look at what happens when I've got a minus. So I've got y equals minus sine of x. Again, we're going to go back to the original graph of y equals sine x. What does this negative do to the graph? Have a go at drawing the graph. Press play when you're ready to see the answer. So well done if you've had a go at drawing the graph. Now this time the key bit to remember is that you are reflecting in this x-axis. So I've highlighted the x-axis here in blue. So it's a reflection in the x-axis. That's what this negative here at the front does. So all you've got to do is take the curve that you had originally, and this original curve that looked like where the marker's going down here has been reflected in this blue line, and it just flips over. So it's a reflection in the x-axis. So you need to make sure you know what happens when you put a minus in front of the function. Now the last graph we're going to look at in the family of the sine function is this graph of y equals sine of minus x, where the minus is inside the bracket. Again, I'm going back to the original function y equals sine x. What happens when the minus is in the bracket? Okay, press pause and then press play when you're ready to see the answer. Have a go at drawing out the graph. Okay, so well done if you've drawn the graph like this. Now you'll notice it looks exactly the same as the graph you drew to the last one, but even though it looks the same, it was calculated differently. And this one was calculated by reflecting in the y-axis. So here's the y-axis. The graph originally started at 0, 0 and went up to 1, so to 91. So it went up to this point here. So reflecting in the y-axis goes this way. So you can see it's been highlighted here on the diagram. So we've looked at all the transformations linking all the trig functions with the transformations that you need to know for the exam. The same principles apply for whether it's a cos function or a tan function. You can apply all the rules we've just looked at for the sine family to the other trig graphs. If you've enjoyed this video, please don't forget to like and subscribe. Comment below to let me know what you would like to see in my next video. See you next time!